Now that we know the motivations behind TensorFlow Lite, let's talk more about this tool. tflite was released by Google Brain in 2019 to allow machine learning and especially deep learning models to efficiently run in edge devices. It has been maintained by Google since then. It also powers many of Google's most famous apps like Google Photos, Gmail, Google Translator, and Google Assistant, as well as many popular apps from other great companies like Spotify, Twitter, and Airbnb. The advantages of tflite are directly related to the limitations of the cloud-based approaches. First, the model latency is reduced since there is no round trip to a server. Second, the user's privacy is protected since no data leaves the device. Third, there is no need for an internet connection because the model runs entirely in the user's device. And finally, because we don't need a network connection, the battery consumption is reduced. In summary, after taking this course, you'll be able to develop mobile apps powered by machine learning models that have all of those advantages. Besides all of those benefits, tflite is also cross-platform. You can use TensorFlow Lite to deploy your TensorFlow model to Android, iOS, Python, C++, and JavaScript environments easily and following the same pipeline. During this course, you're going to use Python to optimize and convert a model to tflite, and Android to run a model at the edge. However, all of the content presented during this course can be easily applied or adapted to all of the other platforms already supported by tflite, including iOS and JavaScript. To start learning how tflite works, let's take a look at its architecture. The whole pipeline can be summarized by the following picture. There are 4 steps when using tflite to embed a machine learning model. The first step is to select the model to be embedded. tflite assumes the model is already trained, so it can be optimized to make predictions at the edge. Note, by the time this course was being prepared, tflite wasn't able to train a model at the edge, even though Google has already announced it intends to release that feature soon. The second step of the pipeline is to convert the model to a format tflite can interpret at the edge. As we know, machine learning frameworks such as TensorFlow and PyTorch represent models as computational graphs, where each node corresponds to an operation and throughout data flows. That means when we train and export a TensorFlow model, all we have is a computational graph representation. tflite's converting step converts that original graph into a compressed flat buffer with the extension .tflite. Next, the third step of the pipeline corresponds to deploying the .tflite file in the edge device, loading it and running it using tflite's interpreter. Finally, based on the performance presented by the model, it's possible to apply optimization techniques and deploy an even better .tflite file. All of those steps will be discussed with more details throughout this course. During this first week, however, we'll focus on getting to know how to run each of them at a macro level. So first, let's see how we can use Python to convert an already trained TensorFlow model to tflite. As you can see, it's extremely simple. All we need is represented by 3 lines of code. First, we import TensorFlow. Then, we instantiate tflite's converter, passing the TensorFlow model we trained using Keras. Finally, you use that converter to get our tflite model, which is already compatible with all of those many platforms we already discussed. Really simple, isn't it? What about running that compressed model at the edge? Well, here we see the code necessary to run the model in Android. First, we load that tflite flat buffer file generated in the previous step. Then, we instantiate tflite's interpreter. Finally, we run that interpreter to make some predictions in an input image buffer and write the output in another buffer. Again, 3 lines of code.